We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step. We've all heard the story of humanity's first steps on the moon. But what about our last steps?
This is Gene, and as I take man's last step from the surface for some time to come, but we believe not too long into the future, America's challenge of today has forged man's destiny of tomorrow.
In December 1972, two astronauts climbed into a small metal capsule and prepared to return to Earth. The Apollo 17 crew included the first scientists to set foot on the moon, and the astronauts spent more than 3 days exploring. They conducted more experiments and examined more of the surface than any previous mission. This concluded the Apollo program. More than 10 years' work by 500,000 men and women. In a competition between the United States and the Soviet Union, known as the space race, humanity proved that we could walk on the moon. When the Apollo 17 astronauts blasted off, most people thought we would return soon. But we didn't. Apollo hardware sits abandoned on the lunar surface for more than 40 years now, relics of another time.
NASA, the National Aeronautics and Space Administration presents Aeronautics and Space Report. (1966), a year in which aeronautics and space achievements were much in the news, achievements which are expanding man's knowledge. Here is a report on some of those accomplishments. This animation shows how Surveyor 1 looked as it came in for a soft landing on the moon. The date, June 2nd. As evidenced by these photos, a spacecraft can land on the lunar surface, and probably a man can walk on it. Some of the terrain is very similar to our soil. A man would leave footprints as he would in sand. Many rocks dot the moonscape. Future flights will photograph other possible manned landing areas and carry instruments to measure surface hardness, information needed before men land there. Charting actual landing sites for the astronauts is the job of Lunar Orbiter. 2 of the 850-pound satellites have orbited the moon, photographing and mapping wide areas, sometimes sweeping as low as 25 miles above the surface. Here are some of the pictures helping to determine the height and slope of lunar mountains and the depth of craters. These remarkable views show the crater Copernicus. Pictures, too, of the backside of the moon, and a view of Earth from 240,000 miles in space. The Surveyor Lunar Orbiter combination has returned valuable scientific data about the moon, helping pave the way for the first lunar explorers.
Sure. So, a lot of us here at the XPrize Foundation and also at Google, our partners in this, are, space geeks at heart. Grew up watching the shuttle program, or before that the Apollo and programs like that, and realized that space is something that really can light a fire under people of all ages all around the world, get them excited about science and technology, and in addition to all those nice educational goals, actually has some real science and technological direct impact on the lives of people today. So as space agencies, not only here in the US, but around the world, start looking at the moon again. You know, the moon was the object of all of our fascination in the late 60s and early 70s, but we've really forgotten about it since then. The last time something was on the lunar surface was when the Soviets left in 1976. But now everyone is starting to go back, and we have 2 spacecraft currently in orbit around the moon. We have more that will be coming in the next couple months. So we said, okay, it's now time to start shifting our research in that direction once again, and really thinking about how, when we go back to the moon this time, it can be done in a way that's not just restricted to government space agencies and to 12 lucky guys who get to hop around on the surface, but it can involve, you know, all of us in some way, whether that's through telerobotics or, you know, cool online presentations, things like that. So we said maybe there is a prize that we can put out there that will allow very small, very entrepreneurial, cutting-edge companies from around the world to sort of stake their claim and make their place in this industry, and really lower the costs and lower the barrier of entry so that the opportunities in lunar exploration can increase for all of us.
Now, what do the teams actually have to do to win the prize?
Sure. To win the Google Lunar XPrize, a privately funded team, so this is not NASA or another government space agency, this is a private group of individuals from anywhere in the world, has to actually land a robot on the surface of the moon for real. They have to explore the lunar surface by roaming around for a half a kilometer, about a third of a mile. And then they have to take 2 packages of high definition video and very high resolution images that we call mooncasts. And they have to return them back to the surface of the Earth for, you know, adoring fans around the world to watch.
And a big vision. The Google Lunar XPrize has inspired people from around the globe to join a new era of lunar exploration. This $30 million competition will stimulate a new generation of engineers, scientists, and entrepreneurs to think about space as a place to do business, to innovate, and to change the world. So, what do you have to do to win the Google Lunar XPrize? The first challenge is to escape the Earth's gravity. The force that keeps us all grounded works against a spacecraft launch. You want to keep your spacecraft small and lightweight, so you spend as little energy as possible fighting Earth's gravity. Once you're off the ground, you need to cross the 400,000 kilometers to the moon. One small miscalculation, and your spacecraft could end up missing the moon entirely. On the way, you need to make course corrections to avoid smacking straight into the lunar surface. To get into lunar orbit or begin your descent to the moon's surface, you need to slow down. Slowing down requires firing engines at exactly the right moment for the right length of time, so you need precise calculations to end up in orbit. Then you need to find some place to land. You'll probably want to avoid rocky hills and craters and land someplace flat. After making it to the surface, your craft has to either take off again or release a rover or smaller hopper. Then, whether it flies, hops, rolls, or roves, your spacecraft has to travel a distance of 500 meters. To claim the Google Lunar XPrize, you must now initiate your mooncast, take video and pictures, and send them back to Earth so we can all share what your spacecraft can see. But there's one more catch. To win the prize, your team has to be at least 90% privately funded. No governments allowed. That means teams need to keep costs down. If future exploration costs less, we can do more of it. Let's meet people who have taken on the challenge.
3, 2, 1, ignition. We have...
On November 19th, NASA's PhoneSat 2.4 successfully launched into space on board a Minotaur 1 rocket from the Wallops Flight Facility in Virginia. Built at NASA's Ames Research Center, the smartphone-based CubeSat is an improved version of the previous PhoneSat satellites.
2.4 is still a tech demonstration, but it's a complete spacecraft. It's more advanced than the earlier ones, but it's not quite the scientific type of spacecraft that we're working towards, but it's a big step along the way.
The project uses off-the-shelf hardware, as well as a consumer-grade smartphone that provides a built-in operating system, sensors, GPS receivers, and a high-resolution camera. Weighing only 2 pounds, it houses a two-way radio along with reaction wheels that allow ground controllers to stabilize and maneuver the satellite in orbit. It also carries solar panels so it can recharge its batteries, making it possible for the satellite to stay in orbit for its one-year mission. PhoneSat 2.4 is the least expensive satellite to achieve its robust capabilities and represents a unique and innovative use of commercial off-the-shelf parts. The goal of the project is to collect data on the radiation effects on the satellite and to develop new ways to interact with and explore space.